Okay students, so we are going to learn today the topic of trigonometry, a simple concept of trigonometry, right? For 10th class. Okay, so let us quickly jump into the topic. Okay, let me first introduce with the term of trigonometry. What is trigonometry, right? For that, let us go into the basics first, right? First of all, you might be knowing this triangle, right? You might be knowing this triangle. Okay, what kind of triangle is this? This is a right angled triangle, right? This is a right angled triangle. Now students, we know about one of the theorem of right angled triangle. The theorem is Pythagoras theorem, right? Pythagoras theorem. What does this theorem says? That if I have value of the any of the two sides of the triangle, of a right angle triangle, if I will have the value of the any two sides of the right angle triangle, then I can easily get the value of the third side with the help of the Pythagoras theorem, right? Let us elaborate that thing. What does the definition of a Pythagoras theorem says? That it says that if I have the value of the any two sides out of this AB, BC and AC, right? Let us suppose I have the value of side AB as 4. Let us have the value of side BC as 3, right? If I want to find the value of AC, right? What will I do? I will apply Pythagoras theorem. I will apply Pythagoras theorem. What is Pythagoras theorem? It says that AC square is equal to AB square, AC square is equal to AB square plus BC square. It says that AC square is equal to AB square plus BC square. Now, I have the value of AB, right? I have the value of BC. Put the value of AB and BC in this equation. It will give us 4 square plus 3 square is equal to 16 plus 9 is equal to 25, right? Is equal to 25. We have the value of AC square as 25, right? So what will be the value of AC? Square root of 25. It will give me the value of AC as 5. It will give me the value of AC as 5. So what have we done here? We have used the value of any two sides of the right angle triangle to find the value of other side of the right angle triangle. Similarly, if I have the value of AC as 5, I will apply the Pythagoras theorem and find out the value of this side. Similarly, if I have the value of AB and AC and I didn't have the value of BC, then I should apply Pythagoras theorem and I will find the value of BC. Right? So what we are doing in this process is we have sides to identify to find the value of other side. Right? So we are using the value of sides, right? And we are finding the value of other side. But what if I say I have the value of any one side and I have the value of any one angle? Can I find the value of other two sides with the help of the value of one side and an angle? Yes, we can find it. That is nothing but trigonometry, right? Trigonometry, right? Trigonometry is the science of the relation of angles and sides of a right angle triangle. Angles and sides of a right angle triangle. So what does trigonometry says? It is the science of the relation between angles and sides of a right angle triangle. Let us elaborate this thing, right? Let us elaborate this thing. Okay. In Pythagoras theorem, as I have said, that you need any two side. You need any two side to bring the value of the third side, right? To bring the value of the third side, you should have the value of any two sides. But what is trigonometry? Is the science of the relation between angle and sides of a right angle triangle, right? This is a right angle triangle. This is a fixed angle. This is 90 degree, right? If I have the value of this angle, okay, if I have the value of this angle, and if I have the value of any one of these sides, let us suppose I have the value of this side as 5, I can find the value, let us suppose this angle is theta, right? Okay, look, we can express polynomials in terms of variables such as x, y and z, and angles and unknown angles are denoted by the terms theta, beta, alpha, right? Alpha, gamma, right? Alpha, okay? So these are the notations which are used to identify a angle which is a unknown, right? So let us suppose we have the value of this side is 5 and the angle of this angle is theta. Now my question is, can I find the value of this side and the value of this side by just using the value of this side and the value of this angle theta, right? Yes, we can find that. That is nothing but trigonometry, right? Okay, now let us understand trigonometry. Sir, how can we calculate the value of other sides by using a single angle and the value of any one side? So as I have said that we can use the concept of trigonometry, right, for deriving this thing. So what does trigonometry have? Trigonometry have 6 different functions, right? Trigonometry have 6 different functions, or we can say 6 different operators which gives us the relation between sides and angles, right? Which gives us the relation between sides and angles. Now what are those operators? Let us understand that thing. For that, let us take a right angle triangle. Let us take a right angle triangle. For time being, we will name each and every sides, right? A, B and C. For time being, let us suppose this angle is theta. Now understand this thing really carefully, right? Let us say this side is theta. Okay? Now there is one side which is always greater than the other two sides in a right angle triangle, right? This slant side. This side is always greater than the other two sides of a right angle triangle, and this side is called as hypotenuse, right? This side is called as hypotenuse, right? Now understand this thing really carefully. This angle is theta, right? This angle is theta. The side opposite to the angle theta is called as opposite side. So this side is opposite. This side is opposite to angle theta. So it will be called as opposite side. This side is nothing but opposite side. Okay. Now sir, this angle is fixed 90 degree. There can be only two variable angles in right angle triangle. It is this theta and this theta. If I have the value of this theta, this angle, and if I don't have the value of this angle, then my opposite side will be this side. This will be my opposite side. We'll come to this conclusion later, but for time being, let us consider this angle as theta only. Okay? So if this angle is theta, if this angle is theta, this will be its opposite side, okay? This will be its opposite side, okay? And this will be its adjacent side. This side will be called as adjacent side. This side will be called as adjacent side, okay? This side is nothing but adjacent side. Now, sir, you have told that with the help of this angle and any one side, I can bring the value of any other two sides. How, sir? By using the operators of trigonometry. I said that by using the functions of trigonometry, right? There are 6 different functions of trigonometry. We can do this following thing. Okay, let us jump into the first function. What is the first function? The first function is nothing but sine theta. Okay, the first function is nothing but sine theta. Right? Let's suppose this angle is nothing but 60 degree. For time being, let us suppose this angle is 60 degree. Okay. Now come back over here. Sine theta. First function is what is the formula for sine theta? It will be equivalent to opposite upon hypotenuse. It will be equal to opposite upon hypotenuse. Now I have taken this angle as theta. So what is the opposite side of this angle? It is AB. So sine theta will be equal to AB upon hypotenuse. What is hypotenuse? It is fixed, right? It is AC. So this will be AC. Okay, this will be AC. Okay. Now, sir, you have taken the value of 60. Now, what is the sine theta? Means it will be sine 60. It will be sine 60. Right? Now this sine 60. Okay. So, students, we have a preferred value for this sine 60. Right? We have a definite value for this sine 60. Okay. So, what we will do? We will keep that value of sine 60. Right? Suppose it is x. Right? Okay. And if I have the value of the hypotenuse, let us suppose it is 5. So what I will do, I will keep it as AB upon 5, right? Okay, I will having this value of x, I will have this value, so I can easily find AB. So by the help of this calculation, we can bring the value of other side with the help of the value of one side and one angle of a right angle triangle. So this was the first operator. That was sine theta. And its formula is opposite upon hypotenuse. Right? What is opposite? If my theta is this, the opposite side will be AB. So value of sine theta will be equal to AB upon AC. Let us suppose that value of this theta is 60. So we can say sine 60 is equal to AB upon AC. Right? Okay, we can say sine 60 is equal to AB upon AC. I will have the value of, if I will have the value of any of these two sides, right? I will keep the value of any of these two sides, the value of side which I will have. I will keep that value in any of these two sides, and we have the preferred value for sine 60. We have a preferred value for sine 60, right? I will keep that value of sine 60 over here, right? And what I will do, I will find the value of any third other side. Right? So this was the first operator. This was the first operator of first function of trigonometry, which was sine theta. Right? Which was sine theta. Okay? So let us go to the second operator, cos theta. Right? What is the value of cos? What is the formula for cos theta? Cos theta is equal to, look, sine was opposite upon hypotenuse. Cos will be adjacent upon hypotenuse. Right? So cos theta will be equal to according to this triangle, cos theta will be equal to BC upon AC. BC upon AC. It will be equal to BC upon AC. Right? Okay. So this is cos theta. Now the third operator is tan theta. Tan theta will be equal to opposite upon adjacent. Okay, so it will be equal to AB upon AC. You all just copy down these formulas. We will go into the further explanation. We will go into the further explanation ahead. Okay. And then the fourth operator is cot theta. Right? What is the formula for cot theta? It is adjacent upon opposite. So it will be equal to BC upon BA. Okay. Now let us jump into the fifth operator. Sec theta, hypotenuse upon adjacent. So it will be equal to AC upon BC. Okay. Now let us jump to the last operator, that is the cosec theta. Cosec theta will be equal to hypotenuse on opposite. So it will be equal to AC on. Okay, so these are the 6 operators of trigonometry with the help of which you can find the value of all the sides of a triangle by just using an angle and value of any one side of the triangle. Okay, so these are the 6 operators. Of trigonometry, right? As I have said earlier, what if my theta changes? What if my theta changes? Suppose now if my theta is this, so side which is opposite to the angle is called as opposite side. So now this, in previous case my BC was adjacent side because my theta was here. I was knowing this theta. Now if I will have the value of this theta, then now my opposite side will change and it will be now BC. Now BC will be my opposite side. And AB will be my adjacent side. AB will be my adjacent side. Okay. So students, this is very confusing. So you should must know the value of which theta is given. Right? If my theta is here, my opposite side will be here. If my theta is here, my opposite side will be here. Now, this side is always fixed, hypotenuse. It is the largest side of a right angle triangle. It is fixed. Variation is just between opposite side and adjacent side according to the value of the theta that has been given to you. That has been given to you. So now my formulas will not change. Right? My formulas will not change. Let us suppose take sine theta. Sine theta is nothing but previously it was opposite as upon hypotenuse, right? But in previous case my opposite side was AB, but in this case my opposite side is BC. So my sine theta's formula will be the common formula is, general formula is same, opposite upon hypotenuse. But as now my opposite side is changed, it is now BC. It is now BC. So now the value of sine theta will be BC upon AC. Right? So this is the concept. You can apply this concept for all rest other 5 operators. Right? So for all rest other 5 operators, you can apply this concept. Look, this formula is never going to change. Right? Only the side is going to change. Only the side is going to change according to the value of theta which is given to you. If they have given the value of this theta, then your opposite side will be this one. If they have given the value of this theta, right, then your opposite side will be this and your adjacent side will be this. Okay, and if you have given the value of this theta, your opposite side will be this and adjacent will be this. Right? And if they have given the value of this theta, your opposite side will be BC and adjacent side will be AB. Right? So let us jump into the numericals of, or we can say sums of this topic that we have discussed over here. Right? to have the further clarification of what we have learned over here. Right? If you will apply, then only you will completely get to know about this topic. So we will apply now whatever we have learned over here. But before that, you will have to mug up some of the values of defined angles which are given in your textbook. Right? Okay? What are the defined angles that are given? Zero, 30, 45, 60 and 90. Values of these angles for different operators, all the operators, sine, cos, sine theta, cos theta, tan theta, cot theta, sec theta and cosec theta. Right? The value, if I say what is the value of sine 45, so there is a specific table which is given in your textbook. You should go through it, right? So what will be the type of the numerical, right? They will give a right angle triangle. They will give A, B and C. They will give the value of this angle and they will give the value of any one side. Suppose this angle is 60. Let us suppose, let us suppose this angle is 60. Right? And they will give the value of this side. Let us suppose the value of this side is 4. Right? And they will tell us to find the value of this side and this side. So what you will do? What you will do? Sir, we have to find the value of hypotenuse. This is my angle theta, right? So this will be its opposite side and this will be its this will be its adjacent side. I have to bring the value of hypotenuse and I have to bring the value of hypotenuse and adjacent side. So which are those trigonometric functions through which you can find the value of hypotenuse and adjacent? See, in which formulas does the hypotenuse and adjacent comes? Right? Sine theta, right? Cos theta, right? Tan theta. We can use any of the operator. Let us say we will use sine theta. Sine theta is equal to opposite upon hypotenuse. So AB upon BC. Right? What is the value of what is the angle of theta? 60. So sine 60 is equal to 4 upon AC. Now what you will do? I will have to bring the value of sine 60. So go to this table, find out the value of sine theta at the angle of 60. Put that value over here. Okay. So what will be unknown? Only the side of AC will be unknown. So you will get the value of AC. Okay. So what do you have? You have two sides. You have the value of two sides, right? You can apply Pythagoras theorem and you can find the value of this side. Okay, so this is the rough idea of what you have to do in the numericals of trigonometry, right? This was just a general example. These are not the real values. This was just a general example, right? To show you how you can start the numericals of trigonometry. Okay, so thank you for this lecture.